So first we'll hear from Teddi and Coline Mollaret from the IPA Action Group. Afterwards, we're going to hear from Michael Lynn and Deva-Lynn Pokiak, Northumbria University and Tuktoyaktuk, and finally from Annett Bartsch, Permafrost CCI and GlobPermafrost. So we're going to hand the floor over to Teddi and Coline to start.
Yeah, thank you very much for organizing this event, and thank you for hosting us now. So I'm sharing this talk with Teddi, and we are talking now on behalf of every member of the IPA Action Group we are presenting. So it's not only our work. And so the IPA Action Group is called towards an international database of geoelectrical survey on permafrost. So we'll tell you about the motivation of this action group first. Electrical resistivity is a property which is related to ground ice content, which is a key parameter in permafrost science. Monitoring, so ERT monitoring or resistivity monitoring is still rare, even if there is more and more monitoring initiatives around the world. So on the right, you can see some example of annual measurements. So from this, we can actually infer changes in ice or water content, but there are only very few. But however, there are many more single ERT surveys, like hundreds, several hundreds around the world, but they were not included in the database, so they were not accessible actually. And so that's the gap we want to fill, like by creating a database where they can be collected and available to the community, so that they can be repeated also in the future. Like, for example, the red and the yellow points on the right, they were measured once before 2000 and again recently, and they can infer the changes in ice and water content. So that's the goal, actually, to promote repetition of ERT data and to archive the data to make them available and to enable a reanalysis of the full data sets. Next slide, please, Teddi. Yeah, and so that our IPA Action Group is organized. So it actually includes more than, between 50 and 80 scientists interested in permafrost geophysics from a few different countries, 13. And we're organized in different working groups, and we were launched in 2020, and we have the first actually physical meeting during the EUCOP or just prior the EUCOP, and we launched the metadata call 2021, and last year the data call, and we are still welcoming new metadata and data into the database. Next slide. So our main objective of the IPA Action Group is to collect and archive existing historical ERT data and also new ones. So to be able to reprocess all of them in a consistent and transparent way, and to repeat them, so to actually outline strategy for the repetitions, and to be able to make a full database analysis and to publish it, and to make actually all the data available to the community. And so we started with building a database. So this is a structure we wanted to show you. So it includes actually many tables. So we built it with PostgreSQL, and in blue we have the metadata tables. I won't go into details, but if you're interested, don't hesitate to come to us. And then we have the data table in green, and filtering parameters and the inversion parameters, and so that's a lot of different data types. But now Teddi will continue with what's inside actually the database and not only the structure.
Awesome, thanks, Coline. So we built the database. Coline showed you the tables. So there's a complete database built. And the next step was to start populating it with data. So we put out a call for data and we solicited contributions from folks. and basically asked them to fill out 3 different types of data. People would fill out a metadata form. So that's like an Excel spreadsheet, basically, that has information about the site, the PI, the profile characteristics, etc. Of course, we asked for the ERT data itself, and then also topography data if that was available. The next step was to work on a standardized data processing routine. So we accepted the raw data, and there were a couple steps that had to happen to make this data useful. So the first step was to implement a standardized data filtering routine to remove any poor quality data points. So this is an example from the Swiss Alps, and there are some outliers that need to be removed. So by applying a filtering routine to that, we're able to remove some of those poor quality data. And then a very important step as well is inverting the data. So that means taking the data and producing like the goal of the ERT survey, which is this nice cross-sectional image of the Earth's resistivity at the site. So this is the final output here, and we could interpret the blue zone in this image on the right as frozen or ice-rich terrain. So we iteratively tested and updated this automated processing routine in different locations. Here's one in the Seward Peninsula in Alaska, and here's one in Antarctica. So we came up with a set of parameters that worked reasonably well for sites in diverse permafrost environments. And by having this standardized and having everything processed the same, it enables us to make comparisons between data that's collected in different places or at different times, which is really important for this kind of monitoring perspective. So a quick inventory of what's in the database already. We have data from 13 countries, and there's a total of 213 ERT profiles already, and those are shown in the map on the top right of my screen. So lots of data in lots of different places that there's permafrost present, so that's exciting. There's 410 individual ERT surveys so far, and that number is larger than the number of profiles because 39 of those profiles have repeated measurements at the same site at the same ERT line. We have data from 2002 to 2022. So on the bottom right, you can see the temporal distribution of data that's been collected so far. And it's also good to note that this is really just scratching the surface. We know there are many, many more data sets out there that will be included in this database. So this is going to be an ongoing effort to populate the database. We've also been working on a website. So this is not up yet, but we hope it will be soon. But I'll just give you a super quick demo of what this will look like. So we have a map of all the surveys. If you hover over one of those little dots, you can see metadata about that profile. And then we'll also be able to search the database based on a number of different filtering parameters. So here I'll just search for sites as an example that have some kind of anthropogenic surface disturbance. And I can see that there are 18 profiles that meet that criteria. And I'll just zoom in on one. So the map's quite good. You can zoom in really close. This is a site in the Yukon. You can hover over it, see that information, and then you can also click on the point to plot that image of subsurface resistivity at that location. So we're hoping this will be interactive, searchable, and really easy to see the data and download it. So just some kind of ending comments and perspectives. So the IPA Action Group has brought together the international community that's interested in these geoelectrical measurements on permafrost. And so far we have 20 different data contributors from 14 institutions. So it's really, truly a large-scale international collaborative effort. We've built a database, we've populated it with many data sets already. And by making this data accessible, we hope to promote repetitions of historical surveys, as Coline said, to really enable data reanalysis within that changing climatic context, and ultimately to improve our understanding of how permafrost conditions are changing on a global scale. So if you want to get in touch, if you want to share your data and contribute to the database, please feel free to reach out to us. I'll pop the link to the IDGSP website in the chat as well. or you can scan the QR code. And yeah, looking forward to hearing any questions or comments later.
We are going to spotlight Michael Lim and Deva-Lynn Pokiak.
Good evening, everyone, from the UK. I'm Mike Lim. I'm in Newcastle, so Northumbria University in Newcastle in the UK, and I have loads of people to thank, as you can see from the title screen. But really, I'm just going to thank my co-presenter, Deva-Lynn Pokiak, who's joining us from Tuktoyaktuk. So I'm really honoured to be presenting with her. And we're going to be talking about the NUNA project that we both work on, and how we're trying to build collaborations for mitigating the impacts of permafrost thaws. So really sort of solution-orientated research of permafrost thaw. Deva will come in a minute, but I thought we'd start with just talking about the role that funding plays in establishing relationships and appropriate recognition for the key players within permafrost science. We've talked a lot today about the different elements of communities that hold all the local and traditional knowledge, their incredible experience of the sites, and what is priorities in those areas. They have a much better holistic understanding. They're not constrained by discipline, and they're often very, very engaged and proactive with community-based monitoring initiatives, and often they're the ones that commission the engineers to make interventions. This is by no means a comprehensive list, but we also have government scientists who have very good relationships with communities and build extensive data sets because they aren't tied to short-term projects, as in the same way academic researchers are. But maybe academic researchers can push some boundaries and are always striving for more innovation beyond the kind of the standard, which sort of is, you can see how all these elements can come together. In terms of the funding, particularly in Canada, the government funding's very strong, linking government scientists with communities, and consultation is a big part of that. In our work, NRC fund an element, but there are many others like Polar, for example. With the link between academic researchers and government scientists, there's also very well established funding links. So we would go for a grant or a proposal or even a bursary, and that would link us up with these researchers. But there's often a missing link between academic researchers and communities on the physical sciences, so permafrost science sort of in general. And we're very grateful and privileged to be part of the CINUC program, which is the Canada Inuit Nunagat UK funding program. And it tries to link these three funding elements together to support solution-orientated research. And that's enabled us to fund community researchers and support community-based networks in a way that can really try and induce longevity to some of these research practices. And as I say, NUNA is our project, and Deva's going to try and highlight some of these elements as we go through. The other element to say is that this is not by any means an exclusive funding initiative. Tuk is a very dynamic community and has been awarded the Arctic Inspiration Prize, which is fantastic, but also enables flexible funding in this way to support community-based researchers to become the key link in this chain. So I'm going to hand over to Deva to talk through what that looks like in our project.
Hello, everyone, and I'm a little bit nervous, but okay, I'll talk to you about this graph. We've started through the NUNA project, and like what Mike said, it's we're trying to embed co-development between science and research with community involvement towards effective decision making. And early dialogue is important to have with the community and keep that communication going. And that has been done, and it's continued through to having great community leaders. So now they're pushing for solutions and sharing and exchanging knowledges and teaching the youth in our community to also pass on that knowledge to interpret why is it so important in sampling and collecting and analyzing data and also reading it to share towards the community in a proper and useful and evidential way to information to the community where they could understand it. This one is our community is located on permafrost, and due to the warming climates that we're experiencing degrading of the permafrost, and our community is erode. There's a point in our community that we call a point, and that's a place that's experiencing high erosion rates, and there's infrastructure and roads built on that piece of land there, and we've already experienced in having to relocate a few homes, and not only having to have the challenges of relocating some homes, we're facing a challenge on erosion to our grave site. So we're trying to look for mitigation strategies and solutions, having proper decision making from our community leaders. Mike?
Shall I pick up this? So Deva's really shown sort of some of the challenges for the community, but we really wanted to acknowledge that that there's a lot of research that has gone on in the area, and we didn't want to repeat it. This map shows where we are on the Tuktoyaktuk Peninsula, and the big network of government-based sites that research has gone on. The site itself, in terms of the hamlet of Tuktoyaktuk, also has a lot of press to do with storm damage and erosion, but also has a lot of legacy infrastructure that has a potential to release contaminants, and its access routes in terms of the road as well goes through very narrow pinch points and is very susceptible to permafrost thaw. So key elements to be aware of. In terms of how these relationships are building, first of all, with government researchers, Environment Canada has a huge resource of archived video that they have very graciously allowed us access to, and we're now reprocessing to create 3D models and look at decadal change at key community sites. The communities prioritize this, but we're also having great value in the community seeing digital archives of what the landscape was like even a decade ago, and how they can relate that to changes to their fishing camps and hunting camps, for example. This is an example of how we're monitoring change at the point that Deva mentioned. It shows an example of how we've highlighted gaps in sea defences that haven't been maintained particularly well, and Deva might talk about this a little bit later, but it's being exploited by storms of different directions. So we can help the community make decisions on priority areas and also vulnerability under certain conditions. We also do time-lapse camera analysis. Believe it or not, these two sites are the same site 1 year apart, looking very different, but it helps us to contextualize the changes and responses of these sites in response to environmental drivers, and again feed into decisions for the community. We've also, this is a good example of how community responses are very effective. We knew a storm was coming in, and you can see ground temperature data along the bottom with depth, and we were able to install this temperature probe just before the storm hit, and you can see the influence of the warm Beaufort Sea on the thermal image on the right hand side coming over, and these defenses are now failing through thaw, not erosion, not coastal erosion processes. And Deva actually downloaded this data for us for an ArcticNet presentation. So really proud in the way she's able to go from this data-driven collection through analysis to presentation of the findings, as she mentioned. I'm going to skip through this one other than to say ground ice has been mentioned a lot, and we're very conscious of the role that plays in coastal erosion and thaw subsidence. NRC have a test site, and I think Igor is in the meeting, so he's the one who installed all this. And this is active thermosiphons to try and reduce ground temperatures as a solution. And so there are really positive things going on with this. As well as mapping the ground ice, we monitor it, but that's very difficult. There's a challenge there to get complex geophysics data through to this kind of simple interpretation for communities to take action. So we're working on a traffic light system that we're developing for that one. And Deva, do you want to pick this one up as a final example of how communities vary in their response to these approaches?
Mm-hmm. So yeah, this project that we're developing is to be trying to be community-led and community-driven, and it was developed the community's uniqueness about the project, and we formed close collaboration with the researchers, and they found out how important it is to have the community's voice into research that they are doing within our community. And one of them has become up into a project that we've formed, and now that the researchers who've had continuous communication with the community and with the community leaders, that now it's leading to collecting useful data and on potential contaminated areas because of legacy infrastructure. As you can see on the sonar there, there's a sea defense that was there back in I can't remember what year they were using tires as a sea defense for coastal erosion, and now that it hasn't worked very good. So now that it has become waste into our ocean now, and we are using the sonars to help navigate the hunting route for community members who go and harvest and use these ways that are changing because of the climate is changing so much that and erosion that it's changing the route for safe hunting and traveling.
Thanks, Deva. I'm conscious of time, so I'll just finish that up by saying that the two screenshots that you can see on the right-hand side are the difference between Tuktoyaktuk that has focused all its attention. These are community-based sonar maps, freely available, and they've spent all their time looking at the harbour and their infrastructure, whereas the Klavik is another community that's already been mentioned today, but has really concentrated on navigation routes out to hunting and fishing grounds as well. So same technology used by different communities in very different ways. I guess I feel very honored to be part of something where we're watching community members go from being interested observers to active researchers. And, you know, for me, it's a very big deal to be able to present this kind of stuff with Deva. So I'm very pleased to be here. And thanks to Tristan as well for encouraging us to step forward.
Just like to say thanks to my research group too, and my team. They're really supportive on my background and respectful of my community and my home and my background on being a hunter and trapper, and they're teaching me very well on the science side of learning how to read all this, instead of just collecting the samples. And now I'm learning to analyze it, get into labs, and really I feel a privilege to have this opportunity and be able to share it back with the community. And that's one of the big things there is what I would like to do and see in my hometown is for our community to flourish and to get to learn all these great opportunities that are about to come.
Thanks, Michael and Deva. We are going to call up Annett Bartsch.
Welcome. I'm now going to talk about a number of initiatives or projects that have been funded by the European space agencies over the years. So that happened via different programs. So we started off with activities as part of the data user element, then the climate change initiative. And now there are also some recent projects as part of the Polar Science Cluster. One has already been mentioned by Gonzalo Vieira earlier today, the EOFO-PAC project, which is on coastal erosion. I don't have time to talk about all. I will mostly focus on the CCI Permafrost and the AMPAC-Net, which is a very recent activity. But I will start with results. Something what we have learned or what we have obtained recently from the Permafrost CCI datasets. So we only know these records of decline in sea ice extent. And now with the datasets or what we created in Permafrost CCI, we also can do something similar, showing that for permafrost. So that's the average for the Northern Hemisphere over the years with annual records starting 97 going until 2019 at the moment. And so we see this, while sea ice is declining, we see this increasing in temperatures at the same time in the ground. Well, we can split this up for different regions. So there are some regional differences. So these trends are a bit more pronounced for Alaska and Russia, and slightly less for Canada and Greenland on an average. But the trend is we have that everywhere. Now going back to more or less the beginning. So with the modeling, that was started already in the part of the GlobPermafrost. At that time, T-top approach, equilibrium model was used for creating permafrost extent for the Northern Hemisphere, and then also for later on Antarctica, permafrost in the Southern Hemisphere. And so then in the next step in CCI Permafrost, that was then changed to a transient modeling. So a different version of CryoCrit to use. And what is used from satellites is basically land surface temperature until now, MODIS data. And so what is available now, I already shown you the permafrost temperature, but there's also active layer thickness and permafrost extent. So for this time period, 1997 to 2019. And at the same time, so we need to validate the data, and that was really challenging. So different sources have been used and data harmonized, a lot of gap filling. A lot of records couldn't be used due to gaps. And what is always discussed are these data gaps over Russia, but we actually have experienced that there are a lot of gaps. Most of the largest gaps we have actually for Canada. And so that's what we have, or what's completed, these records. And what we have been then doing meanwhile was to look into to improve the soil parameterization of CryoCrit, to develop a circumpolar land cover at 10 meter. That's almost completed, and that's the idea is to use this for a better parameterization of the model, in addition to also using snow data from satellite, and to extend these records. So very soon, new years will be added to this. And in addition, well, it's not only the CryoCrit model applications that are done in Permafrost CCI, it's also there's this rock glacier initiative, and which connects to the already mentioned today, the IPA Action Group that was on rock glacier. And so we have very close links, and have been over the years supporting this IPA Action Group from the project. So what information have we gained so far using CryoCrit within these projects? We had using the original approach with the equilibrium model, could put a number to how much, what's the area actually underlain on the northern hemisphere by permafrost, then using these in several studies, these annual records have been used. For example, in the review, this ground temperature change has been derived. So I've shown you before just this average number change over time. So this is the spatial pattern that we get. Then also the active layer thickness has been used, some news story, and the change for the northern hemisphere has been quantified. Well, the active layer thickness is set with the highest uncertainties due to soil parameterization, for example, but the trends, we can also derive some trends here. Some other things that have been done over the years, like this looking at transects for these changes of lake dynamics, and Guido Große has been mentioning this today already before, that this is now, well, we will have that soon, hopefully then for the entire Arctic available. And then a lot of effort has been put into making use of the Sentinel-1 C-band mission for INSAR, looking at a number of technical issues associated with it, and doing some test cases, some showcases, what one can do with the data. Now, it's well, these data sets are now there. It's just it might be a bit of a challenge to access the data, to find it, and maybe you don't really want to work with the entire record. It's huge data. They're in NetCDF. Maybe you just want to know the record from a certain point. There are some ways to get this information, and we are planning for OICOP and kind of user information event or 2 events where we will show how you can actually access the data and how you can potentially use it. Now, I would like to use a few minutes to say a few words about a new ESA initiative. Actually, it's not just ESA initiative, it's NASA and ESA. NASA and ESA have agreed in 2019, so just before COVID, they have agreed on a collaboration with the topic Arctic methane, or the name Arctic Methane and Permafrost Challenge, what's abbreviated AMPAC. But nothing, or it took then a while until things started, and just last year, first meetings took place, and now we are really, have been starting doing things on the NASA side. Is basically above being contributing. Chip Miller is the contact person here, and on ESA side, ESA has this Polar Science Cluster funding initiative. There's usually it's mostly focusing on sea ice and glaciers, but now we have a few projects in here also related to permafrost. And one is a networking activity where we target gap analysis, and then one project on concentrating on or looking into improvements of methane retrieval from satellites over the Arctic. And this AMPACnet, part of it is the development of a catalog. We benchmarking activities, and a lot of networking activities. Workshops are organized, sessions at conferences, and also summer schools. So we had last summer already a summer school in Norway, and there is one planned actually also for this summer. I hope, well, we are working on this, and maybe the announcement is coming. I hope it's coming soon. And we recently had an in-person workshop in January, where we had colleagues from also from America coming over, and actually, it was a quite big workshop. I thought in person. Where we started to discuss the first things that you would like to do as a community together, and what are the gaps regarding permafrost and methane. So if you want to know more about that, you can look at the webpage. We are just starting to initialize a newsletter, but in principle, there we have a news section where we then post also these plans for workshops and other activities. So thank you for your attention.
Thanks, Annett.